So without further delay, let me turn it over to Kyle Lichtenberg, Solutions Architect with Amazon Web Services.
Hey, thanks, Maya. Good morning, good afternoon, good evening, everyone, wherever you're joining us from. Thank you very much for making the time to come out here today and hear a little bit about AWS and Librato and see how we can make your technical lives a little bit easier. So before we dive too deep into the metrics of things, I just wanted to take a quick run through of an overview of AWS and talk to you a little bit about how companies are using AWS. We see three primary areas where companies are leveraging AWS and cloud computing in general as a use case to move in this direction. Number one, they augment on-premise resources with cloud capacity. So if you have existing resources in a data center that you're currently managing, a lot of people are looking to AWS for additional resources as opposed to purchasing additional hardware locally that will need to be managed and monitored and controlled in that scenario. We see people migrating existing applications and data into the cloud. So taking applications that are currently on site and moving those into a cloud scenario. So either putting those up as a forklift type move where it's just the same application running in place, or updating the application so it can take advantage of the cloud value proposition with auto scaling and expansion and contraction of resources as necessary to save on the cost of IT as well as improving the performance of those applications for the customers. And we also see born in the cloud applications. People are building new apps, sites, and services exclusively around cloud technologies. We love to see this. We see a lot of this from our startup friends. But we also see a lot of enterprises moving in this direction as well. Since the value proposition is so high for these types of services, everyone is moving in this direction. That's a lot on what enterprises are doing with AWS, but why are they doing it with AWS? It's a common ask. So with traditional infrastructure, you have to guess at how much capacity you'll need over the next 3 to 7 years and pay for it all in one day. With AWS, you only pay for the infrastructure you're using when you're using it. If you don't need it, turn it off and you stop paying for it. It's not an option that you have with traditional infrastructure, but with AWS, we don't want to charge you for things that you are not currently using. Number two, it's got a lower total cost of IT. So since we're operating at such a large scale and we have the ability to lower costs constantly because of this scale, and as our scale increases, we continue to hand those discounts on to our customers to give them the money back that they don't need to be spending on these things because we can get them at a better price. This slide actually says 34 price reductions since AWS's launch. It's actually up to 38, but every time I update my slide, they change it again. So for you guys, I'm going to keep updating my slides so that they keep lowering the prices. I assume those two things are connected so that everyone can keep saving. This whole philosophy comes back from Amazon.com, where we're used to operating at a high-scale, low-margin business, and transferring that over to the data center world and to the hosted computing world. The lower total cost is a natural fit for us. Number three, third reason that people are using AWS, you don't need to guess at the capacity. So number one, you don't have to pay for it up front because you don't have to guess at it. Number two, you can adjust the capacity as needed to meet the demand of your actual customers. So with the elasticity of AWS, you don't have to forecast anymore. You can use the exact amount of compute, the exact amount of resources that are required for your application or for your product or service, and only pay for that amount, giving your users the best scenario, the best possible experience, and keeping your cost of IT low. Number four, increased innovation. Since the cost of experimenting is so low and the time to stand up an experiment and the time to stand up new infrastructure is also low, the risk of experimenting is low. So instead of needing to worry about ordering additional racks of servers because you want to try out a new concept or a new line of business, you can simply spin those things up in a matter of minutes, try them out, see if they work. If not, shut them down, and your experiment is much more cost effective. And if they do work, you're already on a highly available, highly performant platform that will allow you to turn that experiment into an actual product. Number five, get rid of undifferentiated heavy lifting. Most of our customers are not in the business of running data centers. If you are, you may have some experience in this area. If not, we can handle things like pulling the cable and racking the servers and plugging in the storage and monitoring the building, the things that don't actually differentiate one company from another in this area. So if your company's job is selling T-shirts online, no matter how good you are at plugging in servers, it's not going to make you better at selling T-shirts online. So these are things that we can take off your plate to remove the undifferentiated heavy lifting. We can handle all these things for you with the efficiency of experts. We have people on staff that are very good at these things so that you don't need to employ people, or you don't need to yourself, be good at these things. You can focus on your core business. Additionally, we have 9 regions at AWS. We make it very easy to go global in minutes. With just a few clicks, you can stand up infrastructure all over the world to service your customers without needing to set up expensive purchases for data center space and signing contracts and building all these additional business type requirements that you would normally need if you're going to build a data center or host it in another country. You can do it as an individual person right now, go and start up servers all over the world, and as a business you get the same opportunity. So you have all these options to add resources and to expand, but how do you know when you should? When should you add resources? When should you scale out, scale in, scale up, scale down, whichever type of scaling you happen to be doing at the time? How do you know what impact a traffic spike is having on your infrastructure? How do you know why website requests are taking so long? It all comes down to metrics. So the metrics are what's going to be able to tell you all the data that you need to make decisions on and about your infrastructure. We have a service called Amazon CloudWatch, which is our metrics and monitoring system, and it tracks metrics with between a 1 and 5 minute frequency, depending on the metric and depending on the level of service that you have requested and required for the service. So Amazon CloudWatch by default monitors all of our services, EBS, EC2, RDS, Dynamo, SNS, ELB. All of them have some sort of tie back to CloudWatch so that you can monitor that service effectively. With EC2, you have the option to go to advanced monitoring, which takes the resolution down to a much more granular level. But with most of them, it's a 5 minute check on the standards, and you can also add custom metrics, additional metrics that are important to you. There's an API to push those into the system for monitoring and management. Once these metrics are in the system, and all the standard metrics can be used for alarming and auto-scaling, so we can send out alerts. It can scale based on the data in these screens. And we also have API and dashboard access. So if you want to tie into this externally using our API, or if you want to pull this data up directly in the console, you can do that through the dashboard. But this isn't always enough for everyone. What if you need more granularity? What if you want longer metric retention? What if you want to annotate events when they occur so that you can go back to those and refer to them later? What if you want persistent correlations or templates for data visualizations? Or what if you just want a long-term dashboard that you can look at and know where the data is going to be? One-click type interfaces so that you understand what's going on in your infrastructure. We have a partner, Librato, who's a technology partner with AWS, who takes the ball that we tossed with CloudWatch and really runs with it, builds out a lot of additional functionality, and they've got a very nice, very wide platform that can handle a lot of additional data points in addition to CloudWatch. But they have a great, simple connector to CloudWatch that we love. And I'm going to hand you off now to Joe Ruscio. He's the CTO and co-founder of Librato, and he's going to tell you a little bit more about their product offering and how it can make your life easier.
All right, Kyle. Thanks a lot. All right, everybody. My name's Joe, and I'm here after that introduction just to talk to you a little bit today about Librato and how we can really power up your monitoring metrics game when you're building applications on AWS. So I just have a handful of slides before we're going to actually just drop right into a live demo and kind of like kick the tires and pump some data in and see what we can do. But the first thing, just a brief overview for people who aren't really aware of what Librato is, or if this mailing was your first exposure to us. We're just going to look really quickly at what it's like to develop applications in the 21st century and why you need a platform like Librato to do that effectively. So modern applications, have changed fundamentally just in the last several years, primarily through the actions of vendors like Amazon, where we now deliver applications on ephemeral infrastructure and often used in practice called continuous delivery. And the combination of these two mean that in our infrastructure, change is really the only constant thing. We're shipping, when features become ready in very granular fashion, and we're doing it on servers that we can scale up and down elastically to meet changing demand. Typically as well, we're at larger applications, we're using something service-oriented architecture, which means we're breaking down the responsibilities of the different pieces of our infrastructure into well-defined interfaces, each of which have different SLAs and KPIs that we have to monitor. And finally, this perhaps is not as new, but no two deployments are alike. The requirements and what is important, what you need to monitor in your infrastructure and applications is unique to the business logic and the behaviors that you're encapsulating. So with that in mind, what are the requirements of an ideal monitoring solution for a modern application? And I'd say there's a couple very high-level things. So the first and foremost, I think, very importantly, is that real-time metrics have to be the first-class entity. And that means it's not a server monitoring tool, it's not a particular app monitoring tool, but it's a monitoring platform that you can push arbitrary metrics into. So if anything new in your system you decide you need to measure it, you can go from deciding you want to measure it to measuring it in a small amount of time as possible. Once you're pulling data in, we need the ability to arbitrarily correlate that data up and down the stack and across your different services. So you need to be able to pull in business-level metrics against user-level metrics, against app-level metrics, against system-level metrics on one graph or dashboard based on the changing requirements of your business. Following on that, ideally we want to be able to visualize an alert from the same set of data. So it's an anti-pattern if you have one system that does alerting and a second system that you go and look at a different set of data when an alert comes off, right? We want to be driving both the automated detection of problems as well as firefighting from the same set of data. And lastly, we want this to be fundamentally extensible. I mean, going back to no two deployments being alike, there will be no single one-size-fits-all monitoring tool that you'll be able to apply to two different deployments. And so you're going to need the ability to mold your tools to your particular use case. So with that in mind, we built Librado. And Librado is a true comprehensive monitoring platform. And when we say platform, we really mean that. There are no proprietary agents required to get going. The first-class interface to the system is a RESTful API and with JSON over HTTP. So your engineers, your web developers are already set up with the tools they need to get data into the system. Once your monitoring data is flowing in from wherever you decide to pull it from, we give you a powerful interactive UI that I'm going to demo in just a minute that will allow you to build arbitrary correlations, save those to dashboards. We give you alerting with multiple notification options and integrations to different popular services like PagerDuty, Campfire, and HipChat. And it's fundamentally extensible. We take an API-driven approach to development, and anything you can do in the app and more, you have access to through a comprehensive RESTful API. So you can actually build your own tooling on top of the platform with regards to alerting or visualization or anywhere you want to build custom solutions. And finally, as you'll see later, we have because we've taken such a platform-centric approach, we have a rapidly growing open source software community that are driving a host of integrations behind this that are available for you to take off the shelf. But today we're going to focus in initially on our new CloudWatch integration, which is just one of the ways you can get data into Librado, but is a new awesome capability for anyone who's building their app on top of AWS. And it's very simple to get going. You'll see in the demo, all we require is a single set of read-only IAM credentials. So once again, there's no agents. We have support for every CloudWatch service in every AWS region. And we're going to give you, in addition to a host of other features, definitely pre-configured real-time dashboards for all the services, as well as data retention for a year on top of the 2 weeks you currently get with Amazon. So with that quick intro finished, I'm going to just get set up briefly here, and we're going to actually go into a demo for the rest of my portion. And I'll just actually show you live the things, selection of the things you can do with Librado. Okay, so it's loading the screen share right now. Should just be up in a minute. Okay, so we're going to start very quickly. We're going to log into a demo account and just show how easy it is to integrate with Amazon. So I'm signing into our website. And you can see this just dropped me into an empty demo account. I have just a handful of metrics in here. So if I go to my account settings, and then I click onto integrations, and then I select Amazon CloudWatch. See, I've got a screen here where I can enter my read-only credentials. On our knowledge base, I'll show just briefly here. We've already got the policies you need to set up. It's very simple. It's just read access to CloudWatch and the different resources we'll need to list. All right, I'm going to pull up now a set of credentials we've pre-created. I'm going to put in here. That's my access ID key. And then I'm going to put in my secret access key. I'm going to, the US East region's defaulted. I'm going to leave it as that. And I'm going to come down here and I'm going to select a couple different resources. So I'm going to pick Elastic Compute. I'm going to pick ELB, RDS, and then we'll go with Elasticache as well. And I'll come down and then I will save this setting. And that, I appear to have a copy-paste error on the demo guides here on the credential, but I think you can trust me that will have come in if you've done that correctly. I'm going to just switch over now to an account that's actually fully populated. So you can see, I'm going to come over here. I've searched for AWS on our dashboard listings. And you can see we create for all the different services a pair of dashboards. And so there's 2 dashboards for every service. So I'll just drop in, we'll use EC2 to start. So the first dashboard we call the compact dashboard for a given service. And what the compact dashboard does is for a single instance in this service, this is a template dashboard, which means I can put in a particular EC2 instance. So I've just loaded up a single host in one of our storage clusters. So this is showing all the EC2 metrics in as compact a view as possible. So it's putting the related metrics on the same graph. So we've got our IO ops and IO bytes on the same graph. We've got our health checks, which are all passing on the same graph. And you can see right now I'm showing this on a host, our role is 1. I'm going to switch it now dynamically to a different host. There we go. Sorry, I picked the wrong one there. So now we've got a different host in the same cluster. I'm going to pop back out and select, that was the compact dashboard. Now I'm going to select a dashboard where every CloudWatch metric is on its own graph, and I'm going to actually load up an entire cluster's worth of stats on it. So now I'm looking at, for one of our storage clusters, the different EC2 CloudWatch stats across all the instances in the cluster. You can see we've got tooltips here, which as I hover over are going to show me the numbers for each particular instance. And there's a date picker I'm going to use. It's showing the last hour, but I can switch this entire dashboard to a different period of time. So I'm going to switch that now to the last day. So now we see our stats over the last day. It's rolling up. Okay, it's EC2, but EC2 is probably one of the most common services, but it perhaps is maybe the least interesting. We're going to take a look now at one of the what we call black box resources for Amazon, where the only way you can get metrics about that resource is through CloudWatch. So we're going to look at RDS, and I'm going to load up here now a cluster of RDS instances. All right, so what we're looking at here now is 3 RDS instances. There is a master and then 2 read replicas. So this is a very useful view if you're deploying an RDS cluster where you have access to, like I said, a master, some number of replicas. You can watch the behavior differences between the master and the replicas change. You can see I have all my RDS stats here. Now if I wanted to on this view, I can also zoom into a single, I'm going to zoom into just one read replica. So now I've changed it. Instead of looking at the cluster, I'm looking at just one of the read replicas. And I can do that because of our template dashboards, which we're looking at right now. You can rapidly toggle them from different sources of measurements. I'm going to pop back out one more time, and just to be complete, we're going to show some ELB metrics. So I've loaded up our ELB dashboard, and I'm going to show all the stats. And this is interesting because what this is loading right now, this is a single ELB, but we're showing the different ELB metrics broken out per availability zone that they're serving. So I can see if there are any particularly hotspots or unbalanced places in my load balancing. For instance, here it looks like the number of 3xx's is unnaturally biased towards a single zone. So it's actually something I'll probably look at after this demo. Now, this is just the dashboards. You can also, and this is just a top-level view, let you see at a glance what's going on. We give you the ability to really drill in on any particular instrument, we call it, and see exactly what you want. So right now, this graph is showing me a per zone breakout. But if I want to, for instance, change that and say, well, I just want to see the average latency across all zones, I can see that. Or if I want to change that over instead to the max latency across all 3 zones, I can use this to do that. And I can then change back to the original, showing each zone independently. We have some really nice collaboration features built into this as well. For instance, I'm going to show we have the ability, these are all real-time JavaScript graphs. They're interactive, as you saw. I can also, for instance, I can zoom in or back out for a particular time period. And I can also then take, if I want to share this, I'm going to take a snapshot of this graph. I'm also going to select our Campfire integration. So what this is going to do is, of this real-time client-side graph, it's going to take a permalinked snapshot, provide me. Yep, it's going to come up here in a second. Got a little bit of a screenshot delay. And I can open this now, and you can see that's the graph I was just looking at. And this is an image I can share, I can link to people. And I also, because I selected our Campfire integration, I'm going to pull a window over. And you can see that it pushed the same snapshot into our Campfire room you have here, as well as a link back to the actual instrument. Okay. All right, and we have here on this instrument, we have the same date picker, so I can pull this metric up for the last 3 days, for instance. You can see that. All right, and we have one final, so this is correlation. I'm going to show in a minute how we can build these from scratch. But you see here a link. I can actually even drill into the definition of this particular metric here, which is going to give me the ability to change all the attributes where these show up in different dashboards, like the units they're labeled in, the period the metric is being reported on. I could set here, if I wanted to, what we call a custom display transform. What that allows me to do is scale things, say, from nanoseconds to milliseconds or milliseconds to microseconds. Set the metric color and all these other capabilities. This is also our basic interface here into alerts. So Librado, we have the ability for any signal you're sending into the system, you can set a normal operating range, the minimum maximum threshold, and then you can connect that into any one of our different alerting integrations. And we have support for a host of them, including PagerDuty, Campfire, email. For instance, I'm going to set this over to our PagerDuty hook. We also have custom webhooks as well. So if you wanted to set up your own service, you could have the notification pushed to your custom webhook. I'm going to come back here and actually now demonstrate how I would build one of these graphs here on the fly. So, and also demonstrate very briefly, Scott's going to get into this more, but how you can actually correlate custom application level metrics against, say, your CloudWatch metrics. So I'm going to pull up a metric here, which is measuring latency into one of our application servers. Let's see, it's request. There we go. So you can see I've searched the metrics, and now I've narrowed down my list of available metrics. I'm going to select this one. It's in a template view, so it's going to tell me that I need to pick which instances I want to see this metric for. So I'm going to set this to our production infrastructure. Okay, and that's going to load up for all the instances in our production infrastructure. Then I'm going to come back, and now Kyle mentioned annotations. So we also have the ability in Librado, you can push in one-time or aperiodic events with rich context that you can annotate on your charts. So for instance, what you're seeing on the left, for every service we have in Librado, we submit deploy events. So I'm going to select one of them here. That's going to be added. And we can see this graph in the last hour. There weren't any deploys in the last hour, so I'm going to pull back out to we can go to the last 3 days. Okay, and now you can see two of these lines here, these deploy events, which show when the deploy happened and also what the actual version number of the deploy. And on the left-hand side of the screen, you can see we have a news feed. So if there were many of these annotations, or if you had a lot of deploys, you would actually be able to scroll through them in the news feed on the left. And I'm also, the graph here is a little noisy because we're showing per host. I'm actually just going to change this just again to the average. And so now we're going to see a global view. Last thing I'll do, I'm going to add a title to this. So this is going to be our AWS webinar demo. Right? And then I'm going to save this correlation we just built, this instrument, and we have our save succeeded here. So the last thing we'll do in this demo is show how, given that, we would actually create, while I'm at it, I want to add, I think, one more metric here. So we're actually also going to pull up just an ELB metric just to show correlating. We'll go with sum here. There we go. Okay. So what I did there really quickly is I pulled up one of the CloudWatch metrics, which is the count of 2xx requests through our load balancer. Added, and you can see now what we have is we have two y-axes. We have one on the left and right, so we're showing our application level metric of request time as perceived by our Rails app, and we're showing that against the total number of requests coming in, which we had a spike you can see earlier today, but this didn't affect the average latency, which is what we wanted to see, which means we're not under capacity. All right, so now I'm going to go back, and I'm going to go to my dashboards, and I'm going to create a new dashboard. So we're going to call it our AWS Demo Dashboard, all caps. Okay, and so by creating this new dashboard, it's dropped me into this empty space that I can start adding different correlations to. So I'm going to come in, I'm going to add the webinar demo graph we just created. And then I'm also going to pick probably, we'll look at maybe average latency graphs here. All right, as you can see, I brought up the and the good news here, actually, I brought up one of our error instruments, so we actually don't have any errors in the last hour. So actually, let me add another one that will have something on it here. There we go. Okay. So now what I'm showing is three instruments I've just added to this dashboard in real time here. I've got the one we just created, our webinar demo. I've got connection errors, which is showing us we haven't had any in the last hour. And I pulled up one of the pre-created ones from our CloudWatch integration. And while I'm here, you can see also we can reorganize these. So I'm going to move, and I'm going to change the ordering and put the errors last. And then I think the last thing I'll show here is another great collaboration feature. For any dashboard, you can create an arbitrary number of these private obfuscated URLs. So I'm actually just going to make a new one. Here we go. And I can copy that. Okay. And I'm going to pull over really quickly a incognito window. So this is a browser here that's not logged into any kind of a session. And I'm going to enter the URL I just copied. And you can see it's going to load the dashboard we just created in a read-only mode. So I can't actually add instruments to this version. I can't move them around or delete them. But this is really useful for either putting dashboards up on a wall-mounted display that you don't want to have access credentials on, or sharing with executives or people that you don't want to give full access to your Librado account. We even often share dashboards like this with particular customers that show them stats about their infrastructure. Okay, so that's going to conclude our demo. So I'm going to go back. I'm going to stop the screen share here. All right. Okay, should be ending the screen share. Great. So the last couple things I wanted to close out with is, that was a good demo overview that showed you definitely getting CloudWatch data in and using it, but I think it's important to realize that Librado allows you to correlate and pull in data from much more than just Amazon CloudWatch. We have a growing community of 60-plus different open source integrations, different services, and if you are using any open source monitoring components in your stack today, you almost assuredly already have pieces of software running that know how to talk to Librado. We have a much more comprehensive listing on our website. And just closing out with, I think, just a couple business details. Waiting for the next slide to advance here. So Librado is delivered as software as a service, which is hosted. We're metered. You pay us based purely on the volume of measurements and metrics you're sending us, and that's prorated to the hour, so this should be a very familiar model to AWS users and customers. And we, by default, bill that monthly. By default, we bill that monthly, but we do have annual prepay options. And probably most important, loading here, is we have a host of very happy customers growing. And these are just a small selection that are all using our Amazon CloudWatch integration and using Librado to monitor their infrastructure and applications that they're running on top of Amazon Web Services. And one of these, statuspage.io from the upper left, is actually kind enough to come here today and talk to us a little bit about how they use Librado to monitor their infrastructure. So with that, I think I'll pass off to Scott Klein, who is the CTO, co-founder of statuspage.io, to walk through how they use Librado.
Thank you, Joe. Hello, everyone. Super happy to be here today. Let me go ahead and kick on the screen sharing 1 second. Lost my little box. All right. So as Joe said, my name is Scott. I'm the founder of StatusPage. Definitely happy to be here with you guys today to talk about how we've used Librado since the inception of the company to monitor what we do and make sure that we have a good insight into what's going on inside of our stack. So for those of you who aren't familiar with what we do, StatusPage is a SaaS tool that lets you create and publish a publicly facing status page for your customers. So whenever you're having unplanned outages, performance degradations, scheduled maintenance, StatusPage is going to be the source of truth for your customers and your internal stakeholders as you communicate around whatever's going wrong. So what you're looking at right now is Bitbucket StatusPage. And they're a customer of ours. And Bitbucket makes this page available to all of their customers so that they can be super transparent and know what's going on in terms of the product that they're delivering as a SaaS product. Now, customers of Bitbucket can come to this page and they can put in their email address or their phone number to be proactively notified around incidents or scheduled maintenances as they occur. And what we do is we drive traffic to incident report pages where customers can get the full details of what's going on. Now, you can see how these pages would get a lot of traffic, especially for bigger customers that we have like Bitbucket. And so we, as a website, we have an incredibly elastic traffic profile. And Librado helps us sniff out who is sending us traffic and how our servers are responding. And one final thing that we do is that we let customers put publicly facing metrics on their page. But we don't host any of this data. We actually suck it out of third-party tools like Pingdom or like Librato. Okay, so I'm sure many of you have seen these logos before. We host, status pages for some of the biggest names on the internet, and we have to make sure that these pages are up all the time. They look great. Their customers are being trained that whenever we're down, you're going to go to the status page. This is going to be the source of truth. And so we have to make sure that we can handle load on demand and that we're doing a lot of this stuff in the background to make the experience as seamless as possible. So just to recap the type of stack that we have and its characteristics, we have a multi-tenant system where all the customers are on shared infrastructure. And we oftentimes have to handle 50 or 100 times our baseline traffic if a large customer has an incident in just something like a 10-minute ramp period. Background jobs also will take a huge leap if we have a huge customer with a subscriber base of 3,000 or 5,000 subscribers. We try to get all those notifications out of our pipeline within 60 seconds. So you can see how we have very bursty traffic, we have very bursty background job profiles. And each minute we also have a static, sort of thousands of scrapes that we do out of third parties to get metrics into our system. So this is what our Librado dashboard looks like. It's composed of a mix of application level metrics and server metrics. And we spend most of our day sort of checking on this page because this is the source of truth for us to figure out what's going on inside of our stack. And with just a quick glance, we're able to tell exactly what's going on and if we need to take action on any of the data that's being presented. So some of the great features that we make use of, first one is source breakout. So Librado lets us figure out via source who's sending us the most traffic. We don't want to log a bunch of this data per se because it can be very expensive and a lot of it's just basic GET requests with a little bit of information. And so we forego logging on a lot of that stuff and we just have Librado tell us what the source is for requests coming into status page. We can see our total web throughput and the average request time that it's taking. As well as the CPU utilization of all of the nodes, and these are being pulled in directly from Amazon CloudWatch. And here's a great example of a live incident, and you can see the correlation of a mix of application level and system level metrics as we pull in from AWS CloudWatch. So status page request source was really high, production requests were really high, and as you can see this incident coming to a close and the traffic profile going way down, on this incident, you can see that the CPU utilization starts to taper off, as well as production SQL. Our Sidekick is our background job provider, and so that's sort of staying roughly flat. Now, best of all, and this is something that we definitely have and are excited to have, is we have this awesome TV dashboard at our office. So this stays up 24/7. It refreshes, I think, once every 60 seconds or so. And with just a quick glance, I know exactly what's going on inside of our complete infrastructure stack and if we need to take action on anything. So we're going to go through an example really quickly and sort of talk about how, with no additional tooling, we use Librado and AWS CloudWatch to sort of make changes to our infrastructure and make sure that the changes do really well. So we moved traffic around recently, centralizing traffic for our management portal and our API. Onto a single host, and we wanted to make sure that the CPU utilization on that specific host was doing well. So here's the dashboard that we have, and if you look on the right, you can see that there's a pretty steady jump in CPU, and 40% is a little too high for my taste, and so we just decided to revert it back through going through the load balancer like it was previously, and so we hadn't made the change, and I see just a few minutes later, CPU node down as expected. Now, another one of our big tasks is sending lots of messages. We have an internal SLA with ourselves. We usually like to get, when an incident is opened, all of the messages out of the messaging pipeline in under 60 seconds. And this is a mix of emails and SMS messages. So if I drop into the instrument view for our notification volume, you can see that at this specific time slice, so this is 10:14 a.m. it looks like, we had 0 messages sent out. And as I mouse over to the next minute, 10:15 a.m., you can see that we had 2,834 messages exit in that 60-second window, along with 45 text messages and even 5 webhooks. And as we progress through one more time, you can see that the notification volume dropped back down to 0. And so this is a good way for us to confirm that we are, in fact, getting out all the messages within that 60-second window just using Librado and the application metrics that are coming in through the reporter. So just to recap, we think that Librado and AWS CloudWatch offer us a great composable dashboard with both application level and node level metrics on the same page. Having minute-by-minute performance views and a good bevy of plug-and-play libraries as offered by Librado is great for us. And obviously, the seamless integrations with things like CloudWatch make it, an easy decision for us to stick with Librado.